once we get done with this here. All right, guys, so you need the note sheet out from yesterday, and we're going to go on and finish it up today. So this one here isn't in the note sheet, but I want you to go on and add it so that we can look at one where we have variables in both terms for the difference of perfect cubes. We did this one? Yeah. Yep, okay. Awesome. I couldn't remember if we'd done this one or not. So we'll move on to this one here. This will be the last sum and difference of perfect cubes we'll do for the note sheets. And I want to do this one here mainly because we have a variable as the second term instead of the first. Now we don't have to rearrange it and put the variable first. We can actually leave it as it is here and go on and factor it this way. So again, the first thing we can do is taking the cubed root of both terms to make sure that this is the difference of perfect cubes. And it also helps give us the two terms. Now the cubed root of x cubed is going to be x. Y'all remember what the cubed root of 125 is? Fine. And if not, we could have plugged that into the calculator and it would have given us 5 as well. Now, since this is the difference of perfect cubes, we can go on and get this set up here. Parenthesis with 3 spaces and then a parenthesis with 5. Now, once we get this set up, we can find the signs. And the signs are going to follow the pattern, same, opposite, always end on a positive note. Since our starting sign is negative, for it to be the same, our first sign is going to be negative. Opposite would be positive, and always end on a positive note. So for this one here, it would be negative, positive, positive. Same, opposite, always end on a positive note. Now, since 125 appeared first, we're going to use our 5 first. So in the first space, we would have our 5. And in the big set of parentheses, our first space is going to be 5 squared. And we would have 5 to the first, and then the last one would be 5 to the 0. But anything to the 0 power would be 1. So we don't need to put it down. In the other spaces, we're going to have our x. So there's just going to be x. With the 5 squared would technically be x to the 0, but anything to the 0 power is 1. So we don't have to write it. In the middle, we'll just have x. And in the last one, we're going to have x squared. Any questions on this here before we simplify it down? So we simplify this here, we're going to have 5 minus x times, well, 5 squared is 25, plus 5 times x is 5x, plus, and x squared would be x squared. And we'd have this here. Now, if we wanted to, we could rewrite the second set of parentheses into standard form to make it look a little bit nicer, but either one of these would be factored form. I didn't rearrange the first one because it looks a little weird having negative x plus 5, so I left it as 5 minus x. Any questions on this here? All right. Let's look at the last type of factoring that we're going to look at. And this here is factored by using grouping. Grouping, or as I sometimes call it, greatest common factor twice. Because what we do to factor this here is we're going to group it into even pairs. Since we have 4 terms, we're going to group it in pairs of 2. Now we'll normally group the first 2 together and the last 2 together, and then find the greatest common factor between them, and then find the greatest common factor between those. So when we look at this here, is there a greatest common factor between 2p cubed and 5p squared? There's not a number, but there is a variable, p squared. Because 2p cubed, there are 3 p's there, and 5p squared, there are 2 of them there. So both of them have at least 2. And we can factor those out. So if I factor 2p cubed, if I factor p squared out of 2p cubed, I'm left with 2p plus 5. Because in the second one, the p squared factors out completely. And whenever something factors out completely, if we'd taken the 5 with it, it would just be 1. Plus, what is the greatest common factor between 6p and 15? 3. We can pull out a factor out of positive 3. And if we factor a positive 3 out of 6p and 15, 6 divided by 3 is 2, and we have p. Plus 3 factored out of 15 is 5. Now what's interesting when doing this here is that what's inside the parentheses for both of these here is the exact same thing, yes? So now do both of these terms have something in common? Yes. Use calligraphy pen. Because they both have 2p plus 5, yes? So we can actually factor it out of both terms. Now if I factor it out of our first term, the only thing that's left is our p squared plus 3. And that's it. We have it factored down completely. We might need to check and make sure that there's no greatest common factor in either one of these and that it can't simplify any further. And one of the good ways to check is just looking at the numbers and seeing if there's a greatest common factor, which there's not. But we can also check the exponents, or the degree. Because if we look at the degree of 2p plus 5, what is the degree of 2p plus 5? 1, yes? If it's 1 or less, there's no way you can simplify down any further. What is the degree of p squared plus 3? 2. Anytime there's a degree 2 or greater, we need to double check and make sure it can't go down any further. But for this here, p squared plus 3 is as simplified as it gets. Because if it had been p squared minus 4, that's a degree 2, and it actually can simplify by the difference of perfect squares. But this here is as simplified as it gets. So any other questions on this here? We good with this one here? All right. Let's look at the next one here. Have a good one, Michelle, and I'll have this posted later today. So when we look at this one here, we want to factor it by grouping, because once we hit 4 or more terms, it's going to be easier to factor it by grouping than anything else. So what we can do is we can look at the first 2 terms and the first two terms and the second set of 2 terms. And if I look at 3n cubed and 4n squared, is there a greatest common factor between them? N squared. Because that's about the only thing they do have in common. And if I factor n squared out of 3n cubed, I'm left with 3n. And if we factor n squared out of 4n squared, we're left with 4. And the 3 would be positive. Because if we're not looking to change the signs, because inside the parentheses we need 3n minus 4. So if I factor positive 3 out, well, 3 divided by 9n is going to be 3n minus 4. So we have the two sets of parentheses being the same. Now we can factor the 3n minus 4, because it is in common in both, out, which leaves us with n squared plus 3. And that is as simplified as it gets, because n squared plus 3 will not factor down any further than what it is, and 3n minus 4 is completely factored, because it does have a degree of 1, and there is no greatest common factor between any of the terms. Any other questions on this here? Let's look at one more. Do y'all want to look at this one here or the next one? The next one, okay. So here we want to find the greatest common factor between the two terms. Now we don't necessarily have to stick with these two and these two. We could arrange it in any order, but sometimes it's just easier to pick the first two and last two and find the greatest common factor between them. So do 224 AZ minus 84 YZ plus 56 AC minus 21 YC. Okay? Because it would work either way. So, looking at these first two terms, what is the greatest common factor between 224 AZ and 84 YZ? What do we know for sure that's in common in both? Z. Two would work, but I think there might be a bigger number than 2. 40 would not work, but I think 4 would work. Well, what's 84 divided by 4? So this would be 21y. What's 224 divided by 4? So 4 works out to give us 56a and negative 21y. Okay? That works out that we will have plus. Now, inside the other set of parentheses, we need what? 56a minus 21y, yes? So what do I need to factor out of these, the second two, to get that? We'll need to factor out the c, yes? Do I need to factor out anything else? Because I need 56ac to be what? What do I need to 56ac? What do I need right here? I need it to be minus, because I need the two sets of parentheses to be the exact same. Now, there is a greatest common factor that we can pull out here in a minute, but for us to be able to do the next step, I need both of these sets of parentheses here to be the same, because if they're not the same, then we can't factor it out. If we can factor out 56a minus 21y from both, and from the first we're left with 4z plus c. Because when we factored out the 4z, it worked out that both of them were the same. Because we already had the 56 and 21, so we didn't have to factor anything else out number-wise from these two here because they already matched up with the numbers. We only needed to take out the c. Any questions on this here? So when we look back at this, especially when it wants us to factor it completely, well, the degree of both of these here is 1. So we can't factor using sets of parentheses any further. But is there a greatest common factor between any of these here? Will 7 go into both 56 and 21? Yes. So we'll have to factor it out. 56 divided by 7 is a minus and that there would be the final answer. Any questions on this here? Are you good with this here? Well, and that's it. And I'll put that back up there. Did everybody finish copying that one down?